Greetings to one and all present here. I am Dr. Arul Roselet, Meryline S, Assistant Professor from the Department of Mathematics, Amalore College. I'd like to present today a paper titled A Study of Fully Soft Assignment Model Involving Soft Mode General Class of Linear Octagonal Fuzzy Numbers. This presentation was jointly prepared with Dr. Amalore, Arumica and Dr. Benazir, Obilia from Amalore College. I'd like to present this in this conference ICDTDE2025 during this December month. So the outline of the presentation starts with motivation, problem description, data information, and the mathematical representation and the inferences. So we know in assignment problems plays a major role in operations research problems, locating the appropriate minimal cost and maximum profit. Whenever it deals with the impreciseness, the first assignment problems is being modeled, but whenever the impreciseness along with the characteristics is needed, we need an appropriate tool. So we have developed two papers which involves soft fuzzy environment, which takes care of such environment. So in this paper, we have developed a fully fuzzy soft assignment model. We have collected the primary data, and the cost matrix related to this is quantified using the SMGL offense. So in general, any real life problem, we come across qualitative information. It needs a appropriate quantification. So in our hand, what is the problem? We have an assignment problem where the cost matrix involves characteristics as well as the impreciseness. So it has been quantified using the information associated with the characteristics of the in our case study, like the amenities, interior design, size, and etc. So for our study, we have collected the data from HQ10, and the data has been collected in the proposal format, and the uncertainties involved in is developed using it. So it has 4 office space, 4 departments, and the cost matrix related to the office space is like amenities, interior design, size of the room. So we have to model it into appropriate system. So the problem actually consists of quantification of these characteristics, measuring the cost matrix, and the solution is obtained through the mathematical model, and that has been applied to the primary data, and the appropriate optimal allocation is obtained. So what are the tools? I was speaking about the fuzziness, the impreciseness, or the characteristics involved in it. So how to quantify the fuzziness in nature? So this answer was given by Lot of Sade through his seminal paper, Fuzzy Sets Theory, which plays a major role in sets and the logics. So there is a paradigm shift between the fuzzy sets and the real sets. So it helps to quantify the linguistic concepts. So various problems, wherever there is a qualitative nature, is quantified using the fuzzy numbers. But there are various problems where the assessments or perceptions or linguistics, everything is converted to the fuzzy numbers. But in general, there are various fuzzy numbers in literature, like triangular, trapezoidal, and octagonal fuzzy numbers, which was one of the authors have introduced recently. So this is the definition of the linear octagonal fuzzy numbers, which we will be interested in our paper as well. But this has the 1 K level, which you could see here in this diagram. But we have developed a new octagonal fuzzy numbers where the scale levels is going to be a difference. So you can have a K1 and K2. So you can see the diagram. There is a left down and up, or left up, or the right down. So these possible varieties plays a major role in a psychological problem, which we recently published as well. So for our study, we have considered these kind of octagonal fuzzy numbers. So these are the types of fuzzy numbers. It's the definitions. So you can add these 2 fuzzy numbers, and you can it's been represented here, and these are commutative in nature, and we have a scalar level multiplication of these fuzzy numbers where you can see the K1 and K2 are multiplied by the scalars. So this scalar level multiplication also plays a major role in previous application as well as this current paper. So this level sum also plays a major role, which could be extended for the sum as well. But we know these fuzzy numbers in general are not ordered. So some ranking techniques is needed to order them, and in literature various ranking techniques are available, and appropriate ranking techniques is being developed. So for our fuzzy numbers also, we have developed a measure on MGLOFN, which is given here, which is used for the comparating purpose. But these fuzzy numbers are used only to quantify the imprecise in nature. But when the imprecise in nature come along with your characteristics features, it has to be developed, it has to be quantified, and which is being done using the soft MGLOFN. So what is a soft MGLOFN? It is a function from the parameter set to the collection of MGLOFNs, which is represented as dagger F double tilde. So again, this also cannot be compared, it's not ordered. So in order to order them, we define a measure on it, which is based on the level sum. So you just add all the corresponding fuzzy numbers corresponding to each, associated with each parameter with the level cell, which means which the weight is being multiplied with the level also. So this measure yields a MgLOFN. So again, it has to be compared by making use of the appropriate ranking techniques which is being given here. So these SMGLO is going to play a major role in quantifying any scenario which involves your impreciseness as well as the characteristics. So this SMGLOFN is used in our assignment problem to model the cost matrix. So this is the model that we have developed for, So this is the mathematical formulation that we have developed for the fully assignment problem. So we know the objective function involves the cost matrix multiplied by the allocations. So this cost matrix plays a major role because it's going to give me the intricacies involved in it, because this cost matrix can be related to various characteristics as well, so which is being modeled using MgLOFNs. So let us apply this into the problem that we have developed, that we have collected, the data that we have collected. So the data that we have collected is the 4 rooms associated with the 4 departments. So we want to make an appropriate room allocation with these departments. But what are the rooms characteristics associated? What are the characteristics influencing the rooms? We saw earlier the amenities, interior design, size of the room. So we have taken these as the parameters, and the impreciseness that could arise in nature is associated with these parameters using the SMGLOFN, which, and one such SMGLOFN is being shown here. So likewise for each room corresponding to each department, so your 4x4 matrix will involve your soft MGLOFN numbers. So this has to be given as an input. So a procedure is being developed. So what we do in the first step is we input these soft MgLOFNs and we obtain a MgLOFN by using the measure defined on it, so which we earlier defined using the level sum. So actually the level sum plays a major role because it's going to give the importance of each department corresponding to its each characteristics features. Like the sales department could look for a simple room, or an IT department could look for more facilities, amenities involved in it. So the importance are given by the required person into the characteristics by the required person to allocate the weightages to the different. So that will play a major role in bringing down to the preference cost matrix. So the preference cost matrix is being computed using the the measure on the SMGLOFNs, and then that has been given already developed algorithm by us, fully fuzzy transportation model, fully soft assignment model, where we can apply this is given as an input and we can obtain the solution. So for this purpose we have made use of the software MATLAB 2017 and MathCAD, and these are given as an input and obtain the allocations which is shown here. So what is the major impact of this cost matrix with SMGLOFNs? As I told you earlier, the weightage to the amenities, interior design, size of the rooms gives that preference cost matrix, so which plays a major role in the allocations as well. So this model helps the required person or the department to appropriately choose their weightages to the amenities or to characteristics involved in the problem. So this SMGLOFNs plays a major role in capturing the intricacies involved in the problem, which is related with the impreciseness as well as the characteristics nature in the problem. So in a conclusion, we have utilized the soft MGLOFNs in order to model the assignment problem where the cost matrix has the relations between the characteristics as well as the impreciseness. But we can extend this into any allocation problems wherever there is a need for such preferences in obtaining the cost matrix, and we can also extend it to any other operations research problems in near future. So these are the references that we have made use of. Thank you.